What if I told you that the small things in the universe do not behave like normal objects? An electron can act like a tiny particle, but also like a wave. A particle can exist in multiple possibilities at the same time, and two particles can stay connected even when they are separated by a huge distance. This is not science fiction, this is quantum physics. Today, we will explore the strange world hidden inside the atom and why quantum physics control much of the technology around us. What is quantum physics? Quantum physics is the branch of the science that explains how extremely small things behave. In many study particles smaller than the atom, such as electron, photons, which are particles of the light, photons, protons, neutrons, and other fundamental particles. The word quantum means a tiny packet or a unit. In our small daily life, things behave predictable. A football has one position, car has one speed, and a chair stays where you place it. But at the quantum level, nature follows the rules that seem strange to our everyday brain. Strange to our everyday brain. Scientists discover that the tiny particles do not always behave like tiny balls. Sometimes they act like waves, particles or waves. Imagine throwing a cricket ball towards a wall. The ball hits one point on the wall. Simple. Now imagine wave moving through water. Waves spread out, they overlap, they can create patterns. For a long time, scientists thought light was only a wave. Later, experiment shows that light can also behave like a particle. These particles of light are called photons. The scientists found something even strange. Electrons, which are normally think as a particle, can also behave like a wave. So, at the quantum level, particles can show both particle-like and wave-like behavior. This is called wave-particle duality. If it does not mean that an electron is half particle and half wave. It means its behavior depends on how we observe or measure it. The double slit experiment, one of the most famous experiment in the quantum physics, is the double slit experiment. Imagine a barrier of two small openings. If we throw tiny ball through those openings, we would expect it to the bright lines behave behind the barrier. But when scientists send electrons through the two slits, something unexpected happens. Instead of forming two lines, they created a wave-like interface pattern. It looks as if electrons travel through both slits like a wave and with itself and interfered with itself. But there is strange part. When scientists tried to measure which slit the electrons passes through, the interference pattern disappears. Then the electron behave more like a normal particle. This experiment shows that observation and measure play an important role in quantum systems. Quantum physics does not say that humans create reality with their mind. It means that measuring a tiny system particle interacts with it and change its behavior. Third topic, superpositioning. Now let us talk about superpositioning. In normal life, a switch is either on or off. A coin is either head or tails. But in quantum physics, a particle and can exist in a combination of possible states before it measures. For example, an electron can have different possible position before we measure it. Quantum physics describe it as a spread of possibilities. This is called superpositioning. A famous example is the sculpture of cat. The thought experiment. Imagine a cat in a box connect to a quantum event. Before opening that box, the quantum system is describing as having multiple possible outcomes. The example was never meant to say that the real cats are magically alive and dead at the same time. It was created to show how strange quantum rules become when we try to apply them to large everyday objects. Heisenberg's uncertainty principle. Another major idea is the uncertainty principle. It was proposed by the Heisenberg. It says that we cannot know both the exact position and exact momentum of the quantum particles at the same time. Momentum means mass multiplied by velocity. The more preciously we measure when an electron is, the less preciously we can know how fast and in which direction it is moving. And if we measure its motion more precisely, its exact position become less certain. Its exact position become less certain. This is not because our machines are weak. It is the fundamental feature of the nature. At the quantum level, particles do not have perfectly fixed values for everything at every moment in the way we expect in daily life. Nature itself has a uncertainty built into it. Quantum entanglement. Now comes one of the strangest idea, quantum entanglement. Two particles can become connected in such a way that their properties are linked. Even if they are moved far apart, measuring one particle give information about the other. Einstein famously called this a spooky action at distance. But there is an important point. Entanglement does not allow us to send message faster than the light. We cannot use it like an instant phone call across the universe. Instead, it shows that the quantum particle can have deep connections that classical physics cannot fully explain. Today, scientists use entangled and quantum communication research and quantum computing experiments. Quantum tunneling. In a normal physics, if a ball does not have enough energy to cross a hill, it rolls back. But quantum particle can sometimes appear on the other side of the barrier even when they do not have enough energy to cross it normally. This is called quantum tunneling. It sounds impossible, but it happens in the real world. Quantum tunneling help explains how the sun produces energy through nuclear fusion. It is also used in devices such as scanning tunneling microscope, which allow scientists to study even atoms. Without quantum tunneling, many processes in the star and the modern technology would work very differently. Quantum physics in daily life. Quantum physics may sound distant, but it's already the part of your life. Your smartphone depends upon the semiconductor technology, which is based on the quantum behavior inside the material. Laser works because the electrons can jump between energy level and release photons. Solar panels use quantum effect to turn light into the electricity. Modern computers, medical scanners, LEDs, GPS technologies, and many communication systems are connected to discover from the quantum physics. Quantum physics is not just an abstract idea, it is one of the foundation of the modern civilization. Quantum computer. Normal computer use bits. A bit is either 0 or 1. Quantum computer use quantum bits or qubits. Because of superposition, a qubit can represent more complex possibility than a normal bit. The quantum computer are not automatically better at every task, but for some difficult problem, they may one day solve calculation that would take normal computer and extremely long time. Scientists are exploring quantum computer for areas such as chemistry, material designing, security, and complex simulations. Ending. The quantum physics teaches us that the reality is much stranger than it appears. The universe is not only made of solid objects moving in predictable ways. At the smallest scale, nature is based on possibilities, waves, uncertain and surprising connections. We may not see quantum physics directly, but it is happening inside every atom around us. And perhaps the strange thing is this: tiny quantum world may be the reason the entire universe works in the way it does. Comment below which quantum idea shocked you the most, superpositioning, entanglement, or tunneling, and subscribe for more science videos that make the universe easier to understand.